So when we're setting up these word problems so we can do them, one of two things is going to happen. Either we're going to have like items, so like in this first one we got like DVDs and videos. I don't know why they're not the same, but okay. And then the cost of them. And we make two separate equations out of them. So like for instance, we need to know what we're using first. So it looks like in this one I got DVDs and videos. Now me, I don't like to get real creative with this. I'm going to make D stand for my DVDs. And I'm going to make V stand for my videos. So when I go to write my equations for this, I'm just looking for the number of them the first time through. Now this is the part that gets a little crazy. Okay. Number one, number of items total. I don't know how many DVDs I have right now, so I'm just going to use D. I'm going to use a variable to stand for it. But then I'm going to add however many videos I have. Again, I don't know how many right now. But how many total do I have? Do I know that? Yeah, I was going to say, I know I have 300. So that's going to equal how many of those I have. And this is going to start looking like those problems we've been doing for the past few days. Now when I get to the second part, I'm going to put the cost of the item times the item. Okay, so it looks like DVDs are first. How much do DVDs cost? 25. That's kind of pricey. So I put that with my D. So like $25 times the D. I've got videos next. How much do they cost? 15. And when I bought those 25 DVDs and those 15 videos, or those $15 videos, how much did it cost me total? 5,000. Yeah, and here's what kind of helps me with that. When I'm dealing with the money part of things with this, I always just look for all the things that have dollar signs, and they all go together in that equation. Okay? So when it happens to be money, that gives me a little guidance. Now, normally we'd go ahead and solve this, but for right now, we just want to work on being able to set them up, because solving, that's a little bit different of a deal. We've done that, but we got to get used to this first. We don't want to go crazy with everything. So that's all I'm going to do, and that's all I'm doing on the front with any of these. So I've got to figure out in each of these what my two things are that I'm working with. So let's read this next one and see if we can figure this out. On a summer vacation, you travel 50 hours. You travel by car and by train. You average 65 miles per hour by car and 85 miles per hour by train for a total distance of 3,510 miles. How many hours were you on the train and how many hours were you in the car? What are our two different types of travel that we're doing? Train and car. Okay. So to me, again, it makes sense that C is car and T is train. And normally at the start of these, I just go ahead and write out this part just so I kind of remind myself what goes with what. I may not have to do that forever, but at the start it's a good idea. So I think again with my equations, and I look back up to the top and I go, okay, number of items total. Well, I know I got some car hours and I got some train hours. My first equation is always just going to be the variables. So how many total hours did I do on my trip? 50 hours. So typically that number in the first one is going to be my smaller number I'm working with. But now I got to put quantities on things. So what else do I know about my car speed or my car hours here? Look at those other numbers. What other one goes with the car? 65. So my 65 miles per hour goes with my C. Because all those numbers are going to get used. What about the train? 85, yeah. And I just sort of keep working through there. And then how far did I go? 3,510. Okay, and then I'd go through and solve this. But again, we're just getting used to it, so you're just setting them up right now. But it works that same way on all of these. So notice, we're talking about DVDs and videos once and hours on a vacation the second, but the setup in general is going to keep working the same. So we don't want to make this overly complex. All right, let's see here. At a raffle, $1 and $5 tickets are sold. 502 total tickets are sold. $890 is made from ticket sales. How many type of each ticket is sold? Okay, what are our two things we're working with this time? $1 ones and $5 ones. Now this one's a little bit different because I got to figure out, let's see, what can I use for variables? I guess I could go back to X and Y. Because I really can't use a number on those because, well, that's kind of strange. And if some of you are like, I don't like using different variables anyway, can I just use X and Y every time? You can, but I'd really make sure I use the labels ahead of time then so I don't forget which one's which. That's why I like just using the start of the letter because it kind of reminds me. So I get here and I go, okay, what do you think that first equation's going to look like? We're just looking at number of items. Look at those two above. Yeah, X plus Y, my number of $1 tickets plus my number of $5 tickets, and I sold 502 total. Absolutely. Then I go back and say, okay, what haven't I used yet? So let's see. Now it's going to seem strange. My $1 tickets are $1 each. So I put the 1 with my X because I'm going to make $1 on each one of those I sell. When I get to the second one, for each of my $5 tickets, shock of shocks, I'm going to make $5. Bless you. And then I just look for how much money is at the end. Because again, everything to do with the money is in my second equation. And then I could go through and I could solve that and I could figure out how many of each ticket I sold. But again, for right now, we're very, very content with just kind of figuring out how these set up. So one more on setup, and then we actually get to try a couple of these and actually solve them. All right, we have an office building. We have 332 offices. We have small offices that are 250 square feet. Oh, it's even smaller than this room. And larger offices are 400 square feet. The offices take up a total of 100,850 square feet. That's a lot of square footage. How many small, how many large offices? Okay. What are my two different types of things that I'm working with this time? Small ones and large ones. So I'll go back to doing this. So my S is going to be my small offices. And my L is going to be my large offices. Lots of numbers to play with this time, but we know the first one is always just going to be adding the two variables together because that's just the way these work. But what's that first one going to equal? Right, because the number of each offices, this one tells me how many offices there are. So I'm going to use that number. The second equation talks about quantities or numbers, how big are each of the offices. So my small ones are 250 square feet. So the number of small offices times 250 would tell me how much square footage they take up. The large ones are 400. So I put that with the number of the large offices there are. And then that big old total tells me the amount of square footage once I know what each of those values are. And that's what we're attempting to get situated. Sure. We're going to get to that in a second. We're going to do part of them where we're just setting them up and another part where we're just solving. And if I'm remembering correctly, because I didn't write it on here for you guys on there, I think what I'd set up was we were going to set up the first 10 and the last 4 were actually going to be solved if you're thinking ahead here. So when we get to the back, we're actually going to do a little bit of solving back here. And I'm not going to go crazy and make you do every single one of these because I want to work through a couple of them with you on the other sheet. So I want to work through number 5 and number 7. We'll see about number 8 when we get there. But we're actually going to do the whole thing here. So let's see what we got working. 100 tickets sold to the play. All right. Some were student tickets for $3, and some were adult tickets for $5. The total receipts from tickets was $360. Find the number of student and adult tickets. Okay, first things first. What are our two things that we're working with here? Student tickets and adult tickets. And I know sometimes it can seem kind of a pain. You're like, do I really need to write this stuff down? And a lot of times, though, it just reinforces and lets your brain kind of wrap around what we're doing and where to put things. Because when I write those two things down, then I'm like, okay, just like every other one of these, I'm going to go ahead and I'm going to do S plus A, my student tickets plus my adult tickets.
Would it be equal to 100?
It would, because that's how many tickets in general I did. That's perfect. And then my second equation is where all the money comes into play. How much is a student ticket? $3. How much is an adult ticket? $5. How much money did I take in? Yeah, all the money stuff's in the second one, but this time we're actually going to solve it. We're going to go back to what we've been doing the last couple of days. Unfortunately, when I add down, I don't eliminate a variable because, well, 1 plus 3 is 4 and 1 plus 5 is 6, so nothing cancels. But let's say I wanted to cancel out my s's. Okay, this number's 3. What number do I want this to be if I want to add down and cancel? -3. So I'm just going to multiply by -3. And I think I can squeeze this in here. Let's see. So that -3 is going to distribute all the way through. So we've got -3s and -3a equals -300. I multiplied the -3 to everything. I'm not going to do a darn thing to the ones down below, though. Because now I'll be able to go ahead, add straight down, and hopefully figure out what A is going to be. Because once I write that, now -3 and +3 cancel. That's a good thing. -3 and +5 is 2a. -300 plus 360 is 60. And now I just got one step, and I'm going to know how many adult tickets I sold. And then you're like, well, wait a minute, what about the student ones? If I go back to my original equation, because we always talked about working with the top one, so my second step here, I'm like, okay, so S plus A equals 100, but I know what A is. A is 30. So I'm going to plug that 30 in where the A goes, and I'm only going to be one step away from knowing how many student tickets there are. And there's going to be 70. Okay. So it's not really that bad to just go ahead and finish them off when we get through. We just kind of work it through. Nothing too bad. And that's going to be the same exact thing on all of these. And that's why I'm like, this isn't going to be terrible. It's just going to be something that's a little bit more to work with. Now, we're going to skip number 6 for now because we're kind of on a roll with the money thing here. So we'll keep rolling with the money. So we're going to take a look at 7 next. Now, this got a little more interesting. You have a money jar containing nickels and quarters worth $1.55. The money jar contains 11 coins. How many of each coin do you have? Well, let's see here. This time looks like we've got nickels and we have quarters. So we're getting pretty used to this first equation. It's just adding up the two variables. But what am I going to set that first equation equal to? How many nickels and quarters total have I got? 11. Okay. Now, there's no really other numbers there except that $1.55. Well, I know the $1.55 is what, this is going to add up to. I get that. How do I represent a nickel with a number that I can use in the equation? How do I make that a decimal value that I could actually write down? What's that? 5 cents, yes. But how can I write it? Can I write 5? 0.05. So I've got 0.05 N. And how am I going to represent my quarters? 0.25. Ew. This is a new one for us. We got decimals in places. No big deal, though. We're going to do just like we did up on number 5. If this is 0.05, I want this to be negative 0.05. So I'm going to take this top equation, and this is what we got the calculators for. I'm going to multiply by negative 0.05. All the way through. And I also notice I'm going to run out of room, so I'm going to start over here. So that negative 0.05 goes all the way through. And again, using the calculator to multiply, especially times the 11, is not a bad thing. So once I've multiplied the first one through and added that second one, negative 0.05 and 0.05, okay, they're gone. Negative 0.05 plus 0.25 would be 0.20 Q. And $1.55 minus 55 cents is $1. Now, I'm sure a lot of you might actually, whether you believe it or not, would be able to do this in your head because you're like, well, how many 20 cents are there in $1 is basically what you're asking. But if you're not sure, go to the calculator, not a terrible thing. Find out we got 5 quarters. And just like we've done on the other ones, if I go back to that top equation, I know what Q is now. It's 5. And it just ends up being a pretty simple one-step equation to figure out how many nickels I've got. And that's just kind of the roll that we're getting onto here in doing all of these. I want to do one last one. I'm just going to do 8 with you here, and then I'll give some more specifics on the homework. So we're not going to completely work out every one on the homework. That'd be insane.
I mean, we might as well.
We're going to work out every single one on the homework?
Yeah, we could.
Dang, that'd be some stuff going on there. But I appreciate the offer. I still think we're going to clean that up a little bit. So, all right. So, for number 8, same idea. We've got some TI-83s, we've got some TI-84 plus silvers. We need 30 new calculators. We probably need more than that, to be perfectly honest. If the TI-83 pluses cost $100, the TI-84 plus silvers cost $130, we have a budget of $3,100 for new calculators. How many of each can we buy? All right, let's try this out. So, let's see. So we've got, this is going to be tricky again on the calculating. I'm going to go back to x and y again here. Because when they both start with t, that kind of messes things up. So we'll make x the TI-83, and we'll make y the TI-84s here. We'll have to keep this straight. So let's see. What's my first equation going to look like? X plus y equals 30. My number of TI-83s plus my number of TI-84s equals the 30 calculators I'm going to get. Now we got to put values with them. So how much are the TI-83s? $100. And then my TI-84s are 130. And I have $3,100 total dollars, just like the rest of them have been. We put all the money stuff, or whatever it happens to be, in that second one. So I get here and I go, okay, we'll just keep going like we have. I'm going to get rid of the first one. If I think about it, if I kind of come back up to these other two, I had 3, I multiplied through by negative 3. I had 0.05, I multiplied by negative 0.05. What are we going to multiply by on this one? Negative 100. All the way through. I left myself a little short on room again. So we'll just start up down here. So that negative 100 goes through to every single one of those. And then my bottom one stays exactly the way it is. And this is looking like this could become an interesting situation. We'll have to discuss this. Because I have a feeling I might have had a number that went a little haywire here. Because you're like, well, wait a minute, Mr. H. If we add down, we get 30y. And if we add down, it says 100. That's going to come out a decimal. They're going to let me buy a partial calculator? No. Here's what we're going to do in that situation. Because sometimes life doesn't come out in nice, whole, even numbers. So if you get something like that happening, what did you get if you punched that into the calculator already? What's 100 divided by 30? Yeah, it's like 3.33333, but I can't buy that 0.33333. So in this case, if that happens, I've got to round down. I'm not going to be able to get 3 1/3, so I got to take the closest whole number that I can do, which would be 3. And then I just go to the other equation like I had before. I'm going to plug in that 3, and I'm just going to solve that one. So I still get my 30 calculators. I'm just going to have a little bit of money left over. But again, that's realistic. That happens in life. It doesn't always come out just nice and simple and even. So here's how we're going to set this up on the homework. Even though y'all have been volunteered to completely work out all 14 of these, I think that's a little bit of overkill. So here's what we're going to do instead. The biggest thing with these is learning how to set them up. So I'm going to move this out of the way. All right, so here's how we're going to do the homework. On 1 through 10, we're doing setup only, just like we did on the front of the notes. Set up the expression, you don't have to solve it. On 11 through 14, we're going to set them up, and we're going to solve them. And I don't think you're going to get any funky decimal stuff. So I'm trying to see if I've got any weird ones here. I do see one thing I want to go through with you, and then I will get out of the way. I'm going to go down to number 2 with you. I just want to talk about the setup so we can make sure we're talking about the same thing here, and so this doesn't get too tricky or anything. So number 2, okay. Yellowstone National Park is a popular field trip destination. This year, the senior class at High School A, well, that's really specific, and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 4 vans and 10 buses with 416 students. High School B rented and filled 4 vans and 11 buses with 452 students. Every van had the same number of students as it did in the buses. Find the number of students in each van and each bus. What 2 types of things are we talking about on this one?
Buses and schools.
Buses, I agree with.
And vans.
Buses and vans, okay. Buses and vans. And again, if you want to use X and Y, I say go for it, but however that works. Now, this is a little bit different in that not every one of these is going to have just X and Y. Because if I look at the first school, what would what I underlined look like as an equation? I know somebody wants to gamble with this. Go for it.
4B
Yes.
plus 10B
Yes.
equals 460.
Perfect. Perfect, perfect, perfect. So then we're like, okay, where's the next school at? Okay, here's my next info. What's that one going to look like for my second equation?
4B
4V.
plus 11B
Yes.
equals 450.
Perfect. That's all you're doing for the first 10. I just want you to set them up to make sure everything's going right. Now, will some of them maybe be, like X and Y on the first one? Then maybe. But a lot of them, you're just going to be able to go in there, and they're going to give you everything for one equation together. They're not going to be separated every single time. Again, it can change up on us. Now let me.
What more check is this?
This is starting into homework check 4. This is going to be the first assignment in the next one. Because I always give you at least a couple of days on every assignment. So with the homework check being Monday, I wouldn't give you enough time. At least not by my standards, I wouldn't. All right, let me come to the back here for a minute. Let's pick one on the back. We'll do one on the back together, start to finish. Look, see if one looks trickier than another. If it does, that's the one we're going to tackle. Any of them look trickier than any others back here? 11. It's wordy. All right. Heather and Shanice each improved their yards by planting grass, sod, and ivy. They bought their supplies from the same store. Heather spent $218 on 12 square feet of grass, sod, and 10 pots of ivy. Shanice spent $173 on 7 square feet of grass, sod, and 10 pots of ivy. What's the cost of 1 square foot of grass, sod, and the cost of 1 pot of ivy? Okay. They're being nice. They're telling us here at the end what we got here. So I'm going to call G the grass, and I'm going to call I the ivy. And again, any variables you want, you can do whatever you'd like with. But it looks like our setup is going to work the same way as the last ones did. What's my first equation going to look like?
10I
10I.
plus 12G
Perfect.
equals 218.
All right. I just take what they got. I use my variables when I see the words that go with them. I get that set up. And then I do the same thing with the next one. So like I started with I here, so I got to start with ivy again. I got 10. G is my grass. got 7 of that. And I spent $173. But again, back here, we're going to start actually solving them. But here's the cool thing. They're both 10. I got to tweak one of these just a little.
You gotta make one of them negative.
That's right. I got to make one of them a negative. So I'm going to distribute a negative through. Or if some of you are comfortable, you could just minus instead. So I'm going to leave the first one alone, but down here, I'm going to distribute that negative all the way through. Because now I have what I want. When I add down, 10 and negative 10 cancel. 12 plus negative 7 is 5. 218 minus 173, oops, I almost messed that up, is 45. 45. And then I just do my last step of dividing. So it looks like we're buying, so we got $9 for a square foot of grass sod. Whew, that seems a little pricey. And then to finish it off, I like using the top equation, so that's what I'm going to do. And notice when I got to the second equation, when I got to g, I replaced it with the number I just found for g, the 9. Everything else stays the same. So let's see here. Oops, I just see, what did I do goofy? See, this is where I gotta be careful. I'm sitting here going, wait a minute, that said plus, I turned it into minus all of a sudden. I can't do that. That would have messed me all up. Because then I'd have added instead of subtracting. This would have gotten really pricey. So I want to get I by itself. So I minus what's with it there. And I should have moved this over further because now I'm really going to be pressing it here. All right. Let's come up here. 10i. 218 minus 108 is 110. So see, even I got to be careful. I do some silly stuff. And the Ivy's going to cost $11 a pot. But that's the set, and that's why we're only doing a few of these, why we're not going to go crazy and have you do like 14 of these. So just set up on 1 through 10. And on the rest, even if it's just 1, try to do 12, 13, or 14 before you go. Just so you can kind of see that you can do it on your own and reinforce it. Because I know how this works. If you wait till like Monday or the next homework check, then you're going to forget how this goes. You're going to be like, I don't remember. I'm not going to do it. I know y'all this well by now. So even if it's just 1, just if it's number 12 even. Because it kind of sets up like a couple on the front sheet did. Try it out. See how it goes. We can even look and see how it went for you.